Hello everyone. Welcome to webinar on MIDAS nGen training sessions. Today's training session is on RC building analysis and design. I'm Nivedita Khole, Technical Support Engineer at MIDAS IT. Firstly, I'll introduce you to MIDAS nGen, its application areas. Then we'll have a demonstration on RC building structure. We'll look at some information regarding the support services provided for our users. We'll conclude our session today with a special launch offer, and lastly we'll conduct some question answer session. Alright, now let's go ahead with the introduction to MIDAS nGen. MIDAS nGen is our next generation solution for building analysis and design. The software consists of analysis tool, design tool, as well as drafting tool. So one need not go for multiple software solutions, just get MIDAS nGen and do it all in one. So MIDAS nGen is basically an all-in-one design system. It can have integration of architectural drawing into modeling. Then there are many automated features in the software which we will see today. And there is steel as well as RC optimization when it comes to design. And you can also generate high quality reports from MIDAS nGen itself. Let's look into the application areas of MIDAS nGen. Because of the automation and optimization processes from modeling to report generation, it provides a multidisciplinary and fully integrated solution for a structural designer. So here we have some applications, like you can have apartment buildings, you can have a concrete frame with steel roof, so you can have multi-material in one model itself, car parking building, multi-towered structure, towers having two diaphragms. You can have shell type of structure along with a frame structure. There are some complex facilities that you can also model and analyze and design in MIDAS nGen. As you can see here, you can have drop slabs as well modeled. The element used for the beam is a plate beam element, which can provide us the design and analysis just like a beam. Then we can have curved surface shaped analysis. Another good example of curved surface shaped analysis is right in front of you. So we can easily generate these kind of shells and perform stress analysis. We can have multi-towered structure connected by a single podium. We can specify different diaphragms for each tower and get the results separately for each tower. Example, drift. Steel frames as well as RC frames can be easily modeled, and optimal design for both steel and RC frame is possible in MIDAS nGen. By looking at the contour in the program itself, we can understand if the design results are passing or failing, and then accordingly we can go ahead with the optimization. Alright, basically optimization, or we can try to make the members be in a target ratio that is given, like 0.6 to 0.9. Alright, we'll go ahead now. MIDAS support services are there, like today's example. We are conducting training sessions for our users and those who are interested in MIDAS nGen. So such kind of training sessions will be conducted. Also, we can get technical materials through videos. And if in case you have your own personal questions, you can send it us on our website, or you can send it us on our emails. Alright, so that's about the technical support provided to you. And we can also conduct such kind of webinar sessions for your company as well, specifically. Alright, so now let's go ahead to the main part of today's session, that is the demonstration of RC structure in MIDAS nGen. So right now in front of you we have MIDAS nGen software solution. Let me quickly go through the user interface, even though last session was in which we had seen the introduction to the user interface. But since the new people have also joined, so we are going to be going ahead with the introduction in short. All right. So here we have the ribbon menu at the top, and this ribbon menu is divided into different tabs. And these are basically arranged from left to right for workflow streamline. So we have the modeling, the first four tabs, then we apply the loading, then we apply the boundary, perform the analysis, then perform the design, and check the analysis and design results. Then we can generate reports and drawings. Right, so that's one thing. Next is about the tree menu. We have got over here 5 tree menus. The first tree menu is the model tree menu, which will display the analysis, and here we design tree menu for design parameters and different groups that will be generated. Then further there is a display tree menu as well. You can change the style dark by double clicking, light by double clicking. You can have different views generated. We will see that. And we have a table tree menu which can generate tables of modeling, loading, masses, results provided by the program. So that's thing. Then further we have this property menu right over here for any information regarding a selected member. Then further at the bottom we have got the message window. So this message window will tell us about any errors or warnings while we are giving the command or while the analysis is being performed. At the bottom over here there is a unit system which can be modified at any point of time. So right now it's in Newton meter. I'll change it to kilonewton meter for easy load application. Further, we have got some good tools over here like CAD tools, like snapping tools, then auto-intersecting options, orthogonal option, then gripping on and off, constraints on and off. So these really good tools that are like useful for CAD type of drawings can be utilized in MIDAS nGen. Alright, so let us start now with the modeling. Last time we had seen different types of modeling features in MIDAS nGen. One is by tracing the architectural drawing. You can trace structural drawing as well. Then you can import the 2D, 3D, AutoCAD, DWG or DXF files. Then further you can, the next other type of modeling is defining grid lines and then generating members on it. One method is by directly creating your members using coordinates. Then further we have this body type of modeling feature. That means you can keep on sketching and then you can convert convert your lines or your faces into members like beams, columns and slabs. Then we have last type of modeling, which is importing. So you can import Miras Gen MGD file, which can be generated out of Revit or Tekla files. And you can have stat file and parasolid file imported in MIDAS nGen as well. So that's about different types of modelings that you can utilize for your structure. For today's session, we are going to see how to create a tracing file and then trace that file in MIDAS nGen. So let's begin with that. I'll open up Miras Drawing so that we will understand how a tracing file is generated. Miras Drawing is automatically installed when you're installing Midas nGen. Alright, so we have Miras Drawing in front of us. It is having its interface very much similar to AutoCAD. This is a 2D interface basically, and for taking any drawing, DXF or DWG drawing in Midas Drawing software, then we need to go to the file and say import. Alright, so this is one file that I wish to import. You can also import a DXF file. So this is the file I want to import actually. Alright, so right now in front of us is the foundation drawing with center lines of the columns. Now it's very important for us to understand few things when it comes to tracing of a CAD file. One important part is the center of the column is automatically detected with the help of the center line intersections. So you can say that the center of the column, if you would like to have it over here, then you can actually make the center line starting from here itself, like in center of this column, or you can keep it likewise. When we are tracing, the program will create a section in this way and the center of the column at this location, making an offset automatically. So with the help of center lines, basically I would say that offsets are automatically generated. And these center lines are also useful for tracing beams, or you can even use them for drawing beams on the columns. This is very important because Midas nGen is a member-based modeling tool. So the connection between elements is maintained internally with the help of such important points to be important points. So that's what we have over here. All right. So now we have our DXF file opened up. Now let's go ahead with the next command, which is called as edit grid. All right. So at the bottom of the screen, you can see edit grid written over here. This is a spelling. So you write this command down and press enter, and a dialog box like this will open up. Okay, Miras Drawing is just another program that will be installed along with Midas nGen. A question actually was asked, so I'm repeating this part. Alright, so now we have this edit grid dialog box opened up. What we need to do over here is simply put the center line into the center line box. Alright, we can see over here a preview of what we are selecting. Then we are going to use RCC2, that's the layer that I had created for the columns. Columns could be polyline or they could be single line, no problem. Just need to make sure that these lines which are forming the periphery of the column are in one layer. Alright, so that's column line. Then for the wall line, so I'm going to be selecting the wall and put it over here so that the wall, outer periphery of the wall is also taken. Then rest of our layers can be put into undefined type just for reference or just for visual reference. Alright, so after we have taken the important lines, now we will go ahead and say save. Alright, after clicking on save, we are going to again click on save. And then we'll save this file. So this is a foundation. Let me press _1 and save it again. Alright, now let's close it and close this again and we will go back to MIDAS nGen. After we are done with this procedure, we'll go ahead to tracing file import. Before that, let me tell you that instead of going to create tracing file and opening Miras Drawing, it is better to open Miras Drawing separately first and then importing our DXF or DWG file and then using the edit grid command. Alright, so next is tracing file import. So we click on tracing file import and we open up our foundation_1 drawing and click on open. Now while we are importing this drawing for tracing, it's important for us to understand the scale factor. So if the unit system in the CAD file is meters, then you check it with the unit system you have put in nGen and accordingly you provide scale factor as 1. Alright, you can have more than one number of tracing files for each story level. Alright, so I'm going to be showing over here, demonstrating over here just one, and I'll click on OK. So the tracing file has been imported. One more important part before I go ahead, this important part is that the tracing file that you import in Miras Drawing shall have the version of 2007 and lesser. Alright, so that's what we'll take care of. And the tracing file which will be imported from Midas nGen shall be the one which is created from Miras Drawing. So that's the procedure we need to follow when it comes to Midas nGen tracing. Alright, so we are done over here with importing the tracing CAD file. Now we'll go ahead to the story definition. Alright, so here we'll click on story. There is story set control. Basically, when we have multi-towered structure, we can have more numbers of sets. And also in case you want to analyze two different models in one structure, in one model file itself, then you can specify two story sets and create several analysis cases by using them. So I'm creating one story set and I'll click on OK. Now let's add a new story. So I'll have one story right now generated and I'll have 3 meters as the height and I'll click on OK. Alright, so we have over here the level, we have the height, and this height can be modified from here as well. So you can say 3.5 meters and likewise it will be. Okay, now the CAD drawing that we have imported shall be put over here for that particular floor level. And we can also have a separate level for that CAD drawing. So there is a separate level for the CAD drawing which is with respect to, or it is relative to the level of the story. Alright, so I have put a foundation_1 for the 1F level, which is my foundation, and as well as for the roof level. And after that I'll click on OK. So here we are done with our importing of tracing, and now we're going to use this CAD file for tracing. Now in Miras nGen there are 3 modeling modes. One is a 3D mode, next is a plane mode. You can select any plane and easily draw anything on it. We will use all these 3 modes for example. And there is story mode. Let's use story mode now for tracing our columns and our walls. When we go to the story mode, we can choose from here whichever story we want to go on and work with. So we are on the 1F level, which is our foundation level. Alright, so on this foundation level, we are going to be going to the member tab. Okay, now before going to the member tab, in last session we have seen how to define the material and section properties. So I'll be moving ahead to directly tracing the members. Now we have an advantage over here that when it comes to when it comes to columns and shear walls, we need not specify the section properties and the thickness properties, just need to specify your material property. So by default there are some material properties predefined in the software. We are going to be using Eurocodes in this session. So as you can see over here, the material properties already are defined as per the Eurocode. If you would like to make any modifications in this, you can simply right click and say modify. Alright, so we are here to trace our columns and we have several members available for us. So we'll start firstly with our column. We'll click on create column over here. Next important part is to take care that we are selecting the correct story set. We just have one, so it's T1, and the correct material property. According to this material property, the design will take place. So here we are going to be selecting C3037, and now we're going to be using auto generation of column sections by using the tracing file. So now we will simply create a box around all the columns in our floor plan. The program is going to preview all the columns that are detected, and if you're okay with it, we'll click on apply. Now you can go to the isometric view by clicking on the middle mouse button, and you can see over here how the columns are automatically generated, how each and every section property is automatically created. You can see that in the section tree menu as well. In the tree menu under the section properties, these are the new sections that are generated by the program automatically. It's important for us to also understand how the offsets are created because of the center lines that we had imported. So when this is our column and this is the center line point, then you can see over here how the offset is automatically provided. Alright, so you can also undisplay the section property, and you can see that the center lines are exactly at the locations where the center lines are intersecting. I mean, the center line of the columns are exactly at the location where the center line of the beams are intersecting. Alright, so this is one very important feature that we need to understand. Let's get back to our rendered view. Similarly, we can go ahead and create wall members. In this wall members, again, we have different types of walls that can be modeled in Midas nGen. There is wall plate type of wall plate mesh type of member. So what it will do is it will create the walls like plate elements, like shell elements, and they will be obviously meshed after the analysis has been performed. Then there is wall plate not mesh type of an element. So this is like a special shear wall type of element which does not require meshing. It is actually generated out of two rigid beams at the top and bottom connected by a long column. Then there is wall membrane type. So membrane, again, this is a shear wall type of element. Now wall membrane type will only transfer in plane forces. So in case you are using such kind of a member, you can go ahead with it, or you can use wall plate not meshed. Then further, either we create a reference line, but we need to create an actual shear wall, so we can change this mode to wall type. And then here we are going to be selecting the type of tracing. So we can select two parallel lines in between which the wall should be generated, or we can use closed lines like we have over here. So I'll go again to the top view for a better view and better selection. So I'm now making a box around this wall. So because this particular wall has got all closed lines, these are detected by the program. We can see the preview, and then we click on apply, and then we can see over here in the isometric view that our shear wall is also generated. We can also create our shear walls using 2 points. There are various ways, so I'm showing over here one of the way. I'll go to the top view. Alright. So basically you can click on 2 points and right click, and then you can see over here how a shear wall is generated. Alright, so I'll undo this. Okay. Now further we'll create our beams. So for that we will go to the roof level. We already have our center lines. So we are going to go to the beam type of member, and over here we need to have our section properties for the beams. So there are some section properties already with us. I'll be using the same. So I'm using this 300 by 450. And here we have the options to draw by ourselves using 2 points, or we can use the line segments, or there are some lines itself directly that are that can be taken from the centerline tracing file. Alright, so here we are going to be using both the options, by draw as well as by line segment. Line segment as in the program will automatically intersect all the lines that we have taken from the tracing CAD file. So I'm selecting now all these lines which I want to convert into beam. So this is one method that I'm showing. If you have only lines which are going to be converted into beams, then you can just drag a box around the entire floor plan and make it. But here I have several lines for my centers, so I'm going to be like utilizing one by one type of selection just to be on the safer side. Alright, so basically these are some important things that we need to take care of when we are doing the modeling. So there's a lot of things that we can do over here, like we can do editing over here just after we are done with the modeling of our beam. Alright, so I'm creating these lines, and after I'm done selecting all of these, I'll simply click on apply. And here we go, we are done with creating beams. Okay, so similarly, we can use the draw tool, and we can click on 2 points to create our beam. So this is actually one of the methods. By right clicking, you can go out of the command. Alright, now if you would like to make changes like extend the beam, then you can, as you can see here, this is the beam I wish to extend to the center of my wall. So I simply click on one of the dots, and then I can put it over here on my shear wall. So this is how we can simply extend any of the elements. So these elements are actually divided. I can even ask them to merge these beams together. Alright, so this is done. Actually, there was one line element detected over here, and there was one line element completely running from this location to here. So I deleted a half portion of it, and we are done with our beam modeling. Alright, now after this we will go ahead and create slabs. So for that we will use our slab type of element or slab type of member. And in the slab type of member, again, we have predefined thickness. We can define different types of thicknesses by ourselves as well. Then when it comes to analysis type, that time there are two types of slabs that can be modeled. One is a slab that can take in-plane as well as out-of-plane bending. And there is another slab which is a membrane type, which can only transfer the forces from the slabs to the beams. Like it will not take bending, only in-plane forces. Alright, so let's use this slab membrane type of member. And we have by select option right over here. By select option is like you can select the periphery beams or you can select periphery body lines, which I'll be introducing you after some time. So this is how you can simply go ahead and create the slabs. Now this is a two-way type of a slab which can be converted into one-way as well. So I'll show that after we are done with generating the rest of the slabs. So I'll simply select, all right, and click on apply. Seems like need to check over here if we have all the beams. Okay, so as you can see here, there is one portion of the beam that is not connected to the column, and that's why our slab was not getting generated. So we need to actually be very careful when we are making or when we are selecting the lines to convert into beams. So this one was 300 by 450. I'll click on apply. All right, we'll look at the rendered view now. And this as well, I'll convert back to 300 by 450. All right, so this is how we can modify the section properties. Okay, so yeah, we'll go back to now slab creation and we will select all these line elements. And as you can see here, the preview tells us that yes, the slab can be formed, so you click on apply. Alright, so similarly, I'll go to the top view and I'll start selecting the periphery elements. This is working. This is not, something is not over here available. So you can go ahead and create the slab member type which does require the periphery beams. In case you have got slabs which do not have periphery beams, then you can draw them by yourself. And also you can have few things. Let me just select this completely at once. Okay, and apply. All right, so here again there is an issue, so let's take a look at it. So why we don't have this area as slab? By pressing spacebar, you can also understand. Oh, okay, so enough lines were not selected when I was trying to generate. That's why this slab was not being formed. However, now it's being formed by selecting all the lines correctly. Now click on apply and we're done. All right, so here we go. We are done with creating all the slabs. I'll go to the entire rendered view. Now, yes, how to change the direction of the flow distribution. So we select any of the slab and we can simply change this load distribution to one way. Likewise, so I'll get it back to two-way. Alright, so this is how we can do the modification. Now wherever the plus signs are not there, those are going to be converted into a mesh type of a slab. Alright, so we are done here. Now this was regarding a simple slab which is generated in between all the beams. If you have flat slabs, then there is another procedure. So let me save this model and okay, I'll save this model as session 2. Okay, and I'll save as this model, make it for flat slab. Save. All right, and here I will simply delete, go to the so can put EXF or DWE, 2D or 3D file and convert them into members. So For that, we can go to the Structure tab. Let me firstly undisplay all our tracing files. So for undisplaying tracing files, we are in the Modeling Tree menu, and under that we'll go to the Story, T1, and Roof, and uncheck the CAD tracing, uncheck the CAD tracing from here as well. Alright, so we have got a clear screen. Now we'll go ahead, import our DXF or DWG file. So this is like another type of modeling feature available in Midas nGen that I'm showing over here. So I can open up the flat slab DXF or DWG file, and I'm going to be selecting the outline of my flat slab. And if you check on this type for properties, then automatically the beams or the columns will be generated out of the sections layers that you're selecting. Alright, so I'm not going to be doing that. I'm going to be creating body elements using the file, imported file. Alright, so I have over here the outline, and I'll place it at 3.5 meters. Above the ground, and the scale factor will be 1. You can see the preview over here, and then we'll click on OK. So these that you can see in green are called as body line elements. These body elements can be generated using the Body tab, and these can be actually useful for creating members. Like when it comes to a flat slab, that time I can simply go to the Story, Roof level, okay, flat slab again, and I can select the periphery, or let's say I select all of these, and these have actually selected the outline body lines, and click on Apply. Okay, so we have over here our flat slab generated, and we need to take care of the duplicate flat slabs that are generated so that there is no issue in the load transfer. So we do not want any slab over here. So for that reason, we need to create an opening at this location. So to create the opening, we can go to the openings from in the member tab itself, right over here, and we can draw that opening. So we'll go to the top view now, and we will draw the opening at our lift well area. So I'll go to the draw, sorry, here is the draw, and then I'll click on the points that are forming the center line of my shear wall, and I'll click on Apply. And here we go, we have got an opening for our flat slab. Alright. Similarly, I can also delete this part if I do not want it. And these are the cantilevers which will be automatically connected to your main flat slab with the help of meshing, which will be again automatic. Alright, so we have over here flat slab. Now in case we have got drops to be assigned as well, then we have various options, like we can draw the drops and we can assign. However, I'm going to be using again an importing function so that I have reference for drawing the drops. Right, this session is actually going to be a little bit longer. 3.5 and 1. Alright, so this is the area around my drops, and I'll click on OK. So now I can go to the member and I can click on drop panel over here. I can provide a thickness for my drop panel, let's say 0.5 meters, and then we can click on add over here. Now add can be done by using selection tools like the periphery line elements, or you can go for by draw. So here again I can simply click on all the 4 points and click on apply. So that's one. Then this is the second one, the third one, and the fourth one. Alright, so this is how we can create the slabs, sorry, the drops. 1, 2, and 3. I think this one was not created. Maybe I did something mistakenly. Let me go and add it again. So we're in the 3D mode. Let me go to the story mode. And I'll quickly show how it's generated by just showing 1 so that we don't spend more time on this. So I click on add and I click on the 3 points, the 4 points, and click on apply. So basically over here, excuse me, there is some error over here. Let me try again. Okay, so we have our phase 29 over here, and I'll click on OK. So as we click on OK, we can see over here it's a blue location of the drop that is provided by us, and after we perform the analysis we can actually see this thickness of 0.5 added, and this thickness of 0.5 is including the thickness of the slab. So you need to take care when you're providing the thickness for the drop panel. Alright, so we have seen how to create a flat slab and also how to create a drop panel. Now let's also see how we can have any irregular shaped opening. So for any irregular shaped opening, we can go to the body tab and we can sketch our opening, or we can also import the periphery of the opening like over here we had. And let's do that. Let's create one circle. Okay, so we can create a circle over here. I'll make it of 1.5 diameter, and now we have our body. So using this body, I can go to the member and click on opening, and I'll select, use by select option, click on this circle and click on apply. So as you can see over here, the opening is generated. If there is any different thickness in the flat slabs, like for example, I'll get out of this command first. So example, this slab has got a thinner thickness, then you can simply modify the thickness from here. So you need to firstly create that thickness using the define tool. Define, then there is 2D thickness. So using C3037, I create 0.1 meter and click on OK. Now I select the slab and then I select T100 as the thickness, and that's how I can modify the thickness of the slab. Alright, now it's important if in case you have the difference of thickness in between this particular flat slab area, then you need to divide this flat slab and make an area over there separately for a flat slab. Alright, just like we have a separate slab over here, similarly in between you can make an opening and then create the flat slab in that opening directly. So there are various options which you can utilize, and then you need to select that flat slab and then assign a different thickness to it. Alright, so this is how we have the modeling features for the flat slab in Miras nGen. Now I'll go back to the session 2 model that we had generated earlier. I'm using that file because we have beams, columns, slabs, all types of members are there, and we can finally see how the drawings or how the reports are generated. Designs are also performed by the program. It's a very good thing about Midas nGen, then you can have more than one model file in the same window. So I have this flat slab and I have the session 2 model as well. I can work on both of them simultaneously. Alright, so here we go. We are back to our structure and it has left us at the same place. Let's go back to the 3D and let's see how we can replicate our structure or floor plan on upper stories. So for that we can go to define story again and we can click on add. Alright, so add again and we can use, let's say there are 3 numbers of stories and we are going to be replicating a story. Now again over here we have 2 options. You want to use the lower and these columns or you want to use the upper level and the lower columns. So these 2 options are there. I'm using the second option over here and I click on OK. So right now the height of the first floor level is taken, but you can modify it from here itself. Like for example, for the upper stories you want the height to be 3 meters, so you can change it from here directly to 3 meters and the height of the columns and the shear walls will be automatically modified. So I'll simply copy and paste it here. And over here as well I'll paste it, only the first floor will have 3.5 and then we'll click on OK. So as you can see over here now we can see that there is a different height level for this first level and the upper stories. It's 3 meters. We can also measure our structure with the help of measure option. So you can click on 2 points to see what is the distance. So it's 3.15. I did not click on the correct locations, but you can do that. So it's 3 meters as you can see here. Again 3 meters. And an incorrect location. So anyway, so basically we can click on 2 points and we can see how the distance is, and thereafter we can also delete this display from our screen. Okay, so we are done over here with most of the important tools. One important tool is also check model. The check model tool will help us see any duplicates in the structure. So we can see in the message window there is no duplicated member. Then again we have the option to check if there are any mergeable points. So if at all there is a small gap between 2 points, 2 nodes or 2 elements, then it will definitely give us over here. And you can see over here a small diagram is showing what it exactly means. Then there is check silver faces, so we can do that as well. And after doing all these checks, if we do not receive any information over here, then we are good to go ahead with the next part, that is the loading to our structure. Alright, so we'll go ahead to the loads, and in the loading we can go to the sulfate first. So from left to right we are going. Now here we have definition for the load sets, so that we can go directly from define, or we can click on this toggle box to go to that location wherein we define load sets for dead loads separately and live loads separately. Alright, so we have dead loads, live loads. So I'm putting the sulfate under the dead load set and the scale factor is -1 and click on OK. So we are done applying the sulfate. We can confirm that in the analysis tree menu by expanding the static loads, dead load, and we can see here the sulfate applied. Next, let's go ahead and see how we can apply the beam loads on our beams. So here we can see that the current function can have a selection of beams, columns, braces, subbeams, subcolumn members. If you do not want the columns to be selected, you can just check on the beams, click anywhere on the screen after checking on, and then select from by making a box, and only the beam members will be selected, and you can provide over here the distributed force, say -1, and you can click on apply, use the live loads and provide, no, there is no live load as such, but yeah, you can simply provide any type of loading with the help of load sets on the beams. So I have provided some loading on the beams. Now next let's look at the other types of loadings. Alright, now when it comes to a flat slab, that time we apply usually the pressure load. Alright, so pressure loading is available. We have edge pressure loading as well. So pressure load is basically like you select that flat slab and then you provide the pressure value. So here I'm providing 2 kilonewton per meter square. The type is normal, so you do not need to provide a sign over here. You can see the preview before you click on apply. So pressure loading for the flat slab, and then there is arbitrary loading as well. So arbitrary loading as in you can create a body point, a body line or a body face, and on that you can apply your arbitrary pressure load. So in case any location where the loading is separate, it's additional, then you can simply use the face. Alright, so I'm in the storied roof itself, top view. I'll draw the face. So I'm making any arbitrary face right over here. Alright, and then I go to the loading, arbitrary load, pressure load. Alright, and I'll select this face, and on this face I can provide any loading that I wish to apply. So that's how you can apply additional loading on any area within your flat slab. Alright, let's get back to our normal model, and we'll apply the slab loading on our slabs which are encased between the beams. So here we have slab load type option, which can specify or which can hold all the load cases or load sets that we want to utilize, like the dead loads and live loads can be applied at once. Here we need to take care to apply a negative sign for downward direction of loads. And live load, I'm putting -2. I'll click on add and close. To assign this slab load, we are going to go to slab load over here, and we will select our slabs and apply the slab loading. So to select the slabs, we can actually click on this function right over here, unselect all, check on slab only, and then we can simply make a box around the entire structure. So this is how we have selected all the slabs, and then we can simply go ahead and click on OK. And also we can check if there are 56 numbers of slabs itself or not. So that option is also available by going to the model tab, and we can see the members and superstructure and slabs. So yes, we have 56 numbers of slabs. All of those slabs are selected when we drag around the entire structure, and then click on OK. Alright, so we are done applying the slab loading on our structure. We can see over here what loading has been applied to each and every slab. Now let's go ahead with the wind loading. So wind loading, will directly click on assign wind load. Alright, and then we will see over here that we are applying the wind load based on story. The load name will be wind load. We can generate both the X and Y direction loads directly on the structure. Now eccentricity for the wind loads can be applied from here as well. If you do not wish to apply, you can just click on none. Then we need to apply a function for the wind load. So we'll click on add over here, and we will define the wind load function based on the code selected. Now we have American standard, we have European standard, we have British standard as well for the wind load application. So we are going to be using the European standard, and the program has automatically detected the average roof height. Next important part is a structural factor, which you can also have the value calculated by the program based on the natural frequency. So do not have the values right now, so I'll keep it as 1 itself. And we can also click on this report to actually generate the wind load calculations done by the program. It's a very sophisticated report that is generated in Word file directly by the program in a very short time. So our wind function is defined, which we can utilize over here, and simply click on OK. So wind load has been applied, and now we'll go ahead and apply some static load, static seismic load. Again, over here we can simply go to apply the static seismic load by defining the eccentricity, positive, negative, or none, and then we have the design function to be defined. Just like we did for wind loads, we have American standard, UBC, and European standard and NTC for the definition of seismic loads. And further important part is the approximate period, which can be automatically calculated by the program using the formulae. Alright, and you can simply click on calculate over here and click on OK. I have not checked actually which formula to be used, just because of short time. I'm going to go ahead now with clicking OK. And we can actually click on close and show profile right over here to see how the seismic load has been applied on the structure even before performing the analysis. So at the bottom over here we can see what is the base shear of the structure, and we'll click on OK. This base shear that we just saw is based on this the mass is based on the self-weight. So we need to go to the boundary tab and have loads to mass conversion. For the static seismic or seismic load or eigenvalue analysis, we need to have masses. So those masses can be converted from the loads applied with this option. So I'll make 25% of live loads and 100% of the dead loads, and the mass direction is X, Y itself. I click on OK. So we have the mass applied to the structure, and we have the static seismic load applied to the structure as well. It's in one direction. We can apply in both the directions if we keep the scale factors 1, 1 for each direction. Alright, so that's about the static seismic. We can also apply the dynamic seismic loads, that is by using response spectrum loading, for which we would require to perform the modal analysis. So these are the available ones. We can also apply the displacement loads for our building and imperfection loads as well when it comes to European codes. Alright, so we'll go ahead and apply some supports to our building. So I'll go to the support tab and we will see over here there are predefined fixed and pin type of supports available, or you can have user defined, wherein you can simply select the different degrees of freedom to be constrained at the support locations. So right now I'm going to be making it fixed and going to the front view to select the bottom nodes of my columns and click on OK. So we have applied the supports. In Midas nGen, you can also have foundations assigned to the, or you can draw the foundation in the program, and you can assign the soil supports for soil structure interaction, and you can also have pile supports applied to the structure. So right now I'm going to be using the fixed type of support itself for a basic RC structural analysis and design. Alright, so now we have another option over here, that is auto-generate, and this is the auto-assignment of offset distances, basically like panel zone effect. So we can use this auto-generate, have all members, and click on OK. So this is how we can see the panel zones applied to the structure. Now we can go ahead to the analysis tab and we can go ahead with some analysis settings. Alright, so in the analysis settings we can actually provide the information for meshing of our line elements, meshing of our 2D elements. And this is like too big, so we can actually make it 0.5. Depending on the mesh size, the program is going to perform the analysis, and this basically is important when it comes to a mesh type of slab or flat slab. Alright, then we can have solid elements as well. For that, meshing can also be done automatically. Then further, we'll go ahead to the so in Midas nGen, or in all the Midas software solutions, you can actually have more numbers of processors, or utilize all your processors, and you can also use the GPU acceleration. So this basically will reduce the time required for performing the analysis of huge structures. All right, so you have the solution to spending less time on your structure. So click on OK. We are done with the analysis settings. We can also generate load combinations. This is for the RC member. And here we can say auto generation and click on add. The program will automatically generate all the load combinations for the fundamental, that is ultimate limit state. Then further we can see the serviceability limit state load combinations generated by the program. And we can also see here how the envelopes for each have been also automatically generated by the program. Now let's go ahead to the most important part, that is defining the analysis cases. We can have several analysis cases by simply clicking or checking on the options available over here. So we can have one analysis case wherein our support condition is pinned, one analysis where the support condition is fixed. So such kind of several analysis cases can be applied at the same time to the structure and performed, and then we can check the analysis results as well simultaneously for the analysis, for both the analysis. So this is the first analysis. Then we can also perform modal analysis. In the modal analysis, we have the options to ask the program to automatically create those many mode shapes required for 90% of mass participation. Alright, so that's the thing, and you can click on OK and OK. So we are going to perform two types of analysis. One is a static analysis and another is the modal analysis. Other than that, we can perform the linear buckling analysis and also crane analysis and cracked section analysis. Now I'll directly go to the design part. Before we go to the analysis and run the analysis, we can actually have the design parameters define and run analysis and design both simultaneously. So here we have the design settings. So in the design settings, we can go to the RC and see over here how the partial factors and the strength check parameters for beams, plates, columns and shear walls, everything has been specified, which you can modify. There is rebar information. So this is about the material. You can have different material set standards. So you can have BS and you can have 460, 250 for the main and sub rebars. Then rebar arrangement also can be set by us. Then alternating rebars usually for slabs or foundations, so we can ask to consider that as well. And then comes the checking control, which is nothing but the target ratio that we can provide the program, and accordingly the program will give us the results. So it's very easily we can understand by the way of contours if our members are in the critical state, that is 0.9 to 1 as a ratio. If it is 0.6 to between 0.6 to 0.9, then it's okay. If it is below 0.6, then the member needs to be checked. Maybe you need to reduce the size of the member for optimization. And if there is failure, then you need to change the section size because it's absolutely necessary to increase the size. And then there are members which cannot be checked as well. So that's there, combinations already created. Then comes the design group. For generating drawings, design group is very necessary. So you need to have auto-generate design group at least performed. So automatically the program will select and apply the names for the beams and the columns and the walls and the slabs. So click on OK. And the program is going to take actually a little time for us to apply the groups. All right, we are going to be also checking how we can define the design groups by ourselves and assign it. So we have the steel type. We can select the beam and we can create the set for the group. So I'll say beam over here, and we can provide over here the information by selecting the set, and we can provide over here the name for the beam, let's say B. Alright, and after that we can go to the assign design group, and we can click on this dialog box to make it easy for us to select the beams. So here I'm going to be like selecting all the beams together, and we can put it under one group and click on OK. So that's only done when the same properties are there. So let me uncheck all of them and assign to just few members. Alright, so as you can see over here how that particular group has been applied. Similarly, we can create the groups for the columns and for the slabs. So let me go ahead for the columns, and we can create a group name for the column, add it, and utilize the column. So I'm selecting all these columns, putting under one group. Then I'll also make one for slab. So for the slab again, I'll create a group name as slab, add it, and utilize it for my slabs. Alright, so we have over here the groups defined for the beams, the columns, and the slab. Now we will simply go ahead and run the design. So for running the design along with the analysis, we'll firstly have a design case in which we can select whichever beams, columns, and shear walls or slabs we want to utilize for performing the design, as well as we can select the different cases the results of which you want to utilize for design. So click on OK, and then we'll say run all, which will include the analysis as well as the design. In the design, we can have auto rebar arrangement that can be performed by the program with the help of the information provided right over here. So the maximum rebar and is provided right over here, and the minimum diameter and the maximum diameter sizes all are provided for the mains rebars as well as shear rebars, separately for columns, braces, plates, and so on. And also there will be optimization performed by the program if you go ahead for the modification of the design results. So we'll see that later. So we'll click on OK, and we'll click on yes to continue, because there are some slab elements which we had defined as membrane. However, they will be converted into plate mesh type of members. So the analysis is being performed. We can see how the analysis is performed from here itself. One analysis is completed. Now the modal analysis is being generated, is being performed using the line source iterations. And next part is the design. So now the design is being performed. Alright, so we are done with the analysis as well as the design. Let's firstly take a look at the analysis results. So we go in this analysis results option, and here we have the results like deformations. We can see the displacement of our entire structure. To see the deformed shape, we can check on over here. We can scale up and down the deformation. We can also see the real deformation of the structure. Then we can have values shown on our structure, and in that as well we can have the maximum value displayed, or we can have all the values displayed on our structure. So it will show the results on all the nodes. So that's the thing. Then further you can see the legend at the side. So you can activate, deactivate the legend. You can change the unit system to mm, and we can see the maximum displacement using the dead load is 0.67 mm itself. I'll get back to meters. Similarly, we can get the results for the beam forces, actual forces when it comes to columns, and then further we can get the bending moment diagrams as well. So as you can see, these are the bending moment diagrams displayed by the program. You can select any of the element and right click and say show only, so that only that particular element will be visible, and you can take a look at the values, let's say by element. You can see the results at all the locations. So this is how you can check the results on the screen. Let me right click and show all the elements and make it by model itself. Alright, so we are here with the results for the wall forces as well. So you can see here the forces for each and every individual wall. One good part is that you do not need to specify any pier labels, or you do not need any wall IDs defined for walls in Midas nGen. Then also you can get the results for the slabs using the plate forces and moments. So wherever the plate elements have been utilized, there the plate forces moments will be seen. In Midas nGen, you can also get the stresses for your shear walls. So there is plate stresses, so you can get the stresses as well. You can get the applied forces, you can get the reactions on your structure. So this is the FZ reaction that we can see. This we can look at all the results at the bottom. Alright, so this is how you can get the results on the screen. You can also get these results in the form of tables. So there is analysis results table. You can look at the reaction table, which will be opened up right here at the bottom. You can see all, or you can even do the selection of some nodes, and you can look at the results over here directly. Or you can even look at the combinations. So this is how easily or very efficiently we can understand or interpret the results in Midas nGen software solution. Now let's go to the design part. So we'll go to the design results, and in the design results, let's take a look how the strength check is performed. So here we can see the status. There are many slab members which are green in color, which mean need check. That means they are passing very efficiently and are going below the target ratio, 0.6 in each. Below 0.6. And after that, there are few members which are in the OK region. That means they are having the ratio between 0.6 and 0.9. And there are some critical ones, most of them are critical actually, which are having ratios between 0.9 and 1. They are not failing. None of the elements are failing. Alright, so that's the result we can get. When it comes to reinforcement, we can take a look at these informations, like over here. We have the main rebar area required, and we can get linear creep results as well. Need to specify the information. Then further, we can get results like cracking results, torsional results, ratio of that, shear ratio, bending, and so on. So that's about the beams. Then separately you can get the results for columns. So here we have the main rebar ratio. We can see it from here itself on the screen. And all these results that you can see here are available in the form of table. And these tables can be further taken into Excel sheets. So when it comes to slab, again, we can see here the ratio of the slabs. That's for the shear. and for the bending in the X, positive, negative, and the Y directions, positive and negative. Alright, so these are various results that we can get in the structure. So this is the concrete tension stress, tensile stress, and the compressive stresses that can be provided by the program. Alright, so these are the design results. You can also generate reports of any selected member. So let's say this is one column, I'm selecting a slab and one beam. So you can click on OK. A summary will be displayed right over here with the rebar arrangement. And in case you would like to take a look at the detailed report generated by the program, then as well you can go to the design report right over here, put the detail, and you can take a look for any selected member. As you can see, the program is providing all the formulae as well, which it utilizes along with the beam interaction diagram and tells us the results. So now we are done over here with the design. Now let's see the reports that are generated. The report generation in Midas nGen is very efficient. That is, generate report information. You can say new over here to open report maker in Midas nGen. Alright, now over here in report maker you can put different kinds of stuffs like a cover first, and you can have different chapters, and these chapters can include information like project information. Just drag and drop. So I can provide the name to the chapter like project information, and then the steel materials, concrete materials. I think steel won't be required. Okay, concrete materials. Then further can add some more chapter, and we can provide the information regarding the RC slab list. So you can provide the member list in one of the chapters, which includes the slab list, the column list, and you can have the beam girder list, the wall list by story. Then further you can have the information regarding the loading. So you can provide the information like loads, wind loads, and you can add a chapter named as loading. And put here one load each. Then further you can provide the information regarding the boundaries. So like you can just keep on adding by drag and drop, adding the chapters and so on and so forth. Also the design results can be displayed over here, and even the eigenvalue analysis results. So actually I did not show the eigenvalue analysis results. So let me just take you back over here and quickly get you to the analysis results and see how the model results are displayed by the program. So we have the eigenvalue analysis results table. So this will actually tell us the cycles over here. That is the frequency of the structure, the period of the structure, and also we can see the mass participation, that is percentage of modal effective mass. Total of 6 modes were required to achieve 90% of mass participation for all the 3 modes, like the X and Y direction and the rotational mode. So that's what the program has done. And after that we can go ahead with rely on the results of the response spectrum analysis. Alright, so I'll get back to the report maker. Now once we are done providing all the information from the model, then we simply click on generate all. Alright, by clicking on generate all, the program is going to take the images from the program automatically, the ones that we have saved, and the entire information like the project information, member list, loading, and so on. This is the support condition. Alright, so now once we have made any changes in the model, then all we need to do is say check and update. So what this will do is it will see what all changes have been done in the program, and the new analysis and design results will be automatically reflected in your file. Once you're done with this file, then you can simply export this report to a MIDAS, to a Microsoft Word document. So you save it and then you can utilize it for your reports. This Word report can again be opened up in the report maker, and you can have everything updated in the same file, in the same document. Alright, so that's about the report generator by Midas nGen. Now we can go ahead to see how the drawings are generated by the program. So firstly, we can see the settings. So in the settings, we can see the column layouts which will be generated by the program, the framing plans which you can select, unselect, rebar arrangements as well for each level. And then you can simply click on OK and click on Generate Drawing. By clicking on Generate Drawing, the program will open up Miras Drawing again. This will be automatically opened up basically. You do not need to go back to your desktop and then open Midas Drawing. So here automatically the drawing is, Midas Drawing is opened up, and now we can go to the Drawing Creation menu. In the Drawing Creation menu, we can go to the settings of structural drawings, wherein you can do modification of how the column layout shall be, how the structural plans shall be. And once you are done with these changes, then you do not need to do this modification for your future projects. Okay, so that's about the member list, how you want the rebars to be displayed, and different member type detailings that can be done, rebar positions and legends and so on. Everything can be controlled by the program. And after that, we go again to the Drawing Creation menu, and we can say Generate Structural Plans. So here I'm, confirming the structural plans for all the levels and the columns. So this will generate the structural plans which can be further utilized in a DWG file format or DXF file format. So basically there are a total of 19 drawings that are being generated, out of which 18 are completed. So now we will just wait a little bit for all the drawings to be generated, and then we'll keep it on our floor, workspace, not floor, workspace, anywhere on our workspace. Okay, till the drawings are being generated, let me take a look at the questions. Okay, we have several questions with us. Okay. All right, so one question is, how do you get the pop-up click for going to different views? And that's by simply clicking on the center mouse button, and then we can go to any viewpoint. It's a very convenient feature in Midas nGen. There is a question how to divide the flat slab. Well, to divide the flat slab, we need to go to the body tab itself, and then we have the option over here to divide. Alright, I'll get back to our drawing file. So this is basically how the column layout has been generated by the program. And we can see over here the list of the columns and along with the material properties for all these column sections. And also let's see how the framing sections can be generated. So this framing section actually is based on the cross section of the structure. Alright, so for that we need to go to the floor plan, and let's generate one of the floor plan. It's at 3.5 level. Alright, so here we have our floor plan along with the center lines that we already had on our structure. So we can see over here the information written regarding every slab, how thick the slab is. We can see here the beam list in that floor plan, the wall, basically the slab list, and we can see the column list as well. And for the framing section, we can actually create the information, like I'll make F8, okay, and we can create a section like this. Right, so this is the viewing direction, and I'll specify the insert point right over here. So okay, I think I've done something wrong over here. Basically, we can provide over here the section, and then we can generate the section of that area. So let me just go ahead. I'm taking a little time. Drawing creation, generate frame section. Alright, let's also take a look at how the members list is created by the program. Alright, so here we have for the slabs, the conventional type of slab. So type A, B, C, D are depending on how the reinforcement arrangement is. So here we can see the type C was selected for one of the slabs that we have applied the group for. So we have plain rebars in both the directions, no bending. Then further we can see here there is one beam for which group was defined. So we can see the detailing of that beam in this way. And we have a wall list. There is one thickness itself and the same reinforcement that was provided for all the walls. That's why just one drawing section is provided. And finally, the column list. We had created one group itself for one column, so it has been provided in such a way. Now this is how we can get the drawings generated from Midas and Midas Drawing itself, from Midas nGen. We can also get the different templates for structural drawings directly by the program. And you can also drag and drop the different drawings automatically generated by the program over here. So let me, right now the template is opening up. Okay, till then I'll get back to Midas nGen for the questions. All right, so the one question was how do we see the levels? So basically over here, you can see the levels with the help of different information that can be seen from here. Like basically this is one option for viewing the story levels. You can actually make different names for the levels right over here. All right, there was one question, how to understand the reinforcement required for a beam. So that comes under the design results. So we are in the design results right over here. In the design results, you can take a look at the information from here itself. There is RC, if it's beam, then you can see the main rebar area of reinforcement required. This is the negative reinforcement and positive reinforcement required. Okay, one modeling question regarding slanted beams and slabs. Well, just like in the last session, we had drawn slanted beams for our inclined roof in a steel model. We can draw those slanted beams and slabs as well in Midas nGen for RC structures. If you would like to modify the edges of a flat slab structure, then you can simply click on its nodes. Now let me open up that flat slab model. Yeah, till then we can see over here how the templates are available for RC drawings. So this is the column layout as we saw, then the foundation plan. If we had generated foundations, this is how they will provide us with the drawing. And there is framing plan, then the sections and legend, loading plan, equipment, pad layout as well. And further, these are the table formats. And also yesterday we had not seen how the steel drawings will be generated. However, now I can show from here, this is how the steel sections will be displayed. And we can see here the foundations along with the steel, the framing plans and the section and the truss. So this is the different drawings that can be generated out of Midas nGen or Midas Drawing. Right, so this is it regarding all the information. That means we have utilized the drawings for generating the model, and after that we have generated the drawings as well. Let me get back to MIDAS nGen for the next session, that is the question answer session. This is our flat slab, and yes, there was a question how to modify the edges. So you can simply click on the node or the edges of your slab and you can place it anywhere else. So you can stretch your slab manually as well. Okay. Okay, another question, how a curved slab can be modeled. Curved slab can be modeled easily. You can use body or, that is the best way of creating curved walls, or you can have curved slabs more in like a very efficient way, in a very easy way. So like basically you can have a circle drawn if it's a circular slab. So you have a circle now, and now we'll go to the members, and let's say a circular flat slab. So I select this and click on apply. So we have our circular slab generated. So its best way is to create a body and then utilize the periphery and make the flat slab of any shape. Alright, another question, if we can define our own loads, like if we are in the loading tab, then of course there are manual methods available. If possible, kindly elaborate on your query. Alright, I think we'll go ahead, and if there are any more questions, then please write to us. We are going to be moving ahead to show the special launch offer. So the special launch offer for our users or our attendees, basically, not the users would be after you're done the purchase. So here we have MIDAS nGen, which can generate the model out of the architectural drawings and also take out the structural drawings out of the design results. So we have the entire modeling of substructure, superstructure, analysis and design in one software solution. And with this, by using this one software solution, you can complete your entire project. So for this MIDAS nGen, we are actually having a subscription price for 1 year, that is of $2,400 US. However, we have a special launch price which is 50% off, or it's at just $1,200, which actually averages out to $100 US per month only. This launch offer is available only till 31st March 2019, so you can basically try to make the most of this software solution. All your questions actually will be answered by emails as well, and this video that has been recorded will also be sent to everyone. With this, I would like to thank you all for attending the webinar session. Hope to see you again at the next session, which is on Monday at the same time. All right, thank you everyone. Have a great day.